Hi everyone, my name is Piterpakulski. Today we'll continue building financial model for a manufacturing business idea. So if this video will be useful for you, you may give us a like, subscribe, share this video with your friends. You can also order financial models from scratch for your unique business ideas. We can help you with that. At the end screen of this video, I will be giving the link to the whole playlist where all these tutorials will be placed. And when we will finish this model, I will be giving all the links on these tutorials and in the description of this video as well. So you may watch these tutorials video by video. Today we will finally finish with revenues. Now I would like to remind the process that we already did. So during previous tutorials we were focusing, so we created two products. So blue color is the input color through the whole financial model that we create. So we have two products, product A and product B. So we can switch on and off each product from our financial model. Here we can specify how many units of products we produce hourly. Here we have global and local coefficients to play with these numbers. We will need this later during scenario modeling. We have two production lines. We can switch on and off each line from calculations. And we also can split the time that we produce product A and product B on line 1 and line 2. Here it is. Then we specify when we start operating activity. So this is the year and month when we start operating activity, when we get the first revenues. And then we assume that we have three shifts in each line. We can switch on and off each shift from calculations, and we can specify when each shift appears from the moment when we start operating activity. So the first shift, for example, appears on the first month of operating activity. This shift number 2 appears, for example, on the 20th month of operating activity. This will be July 25. And the third shift appears, for example, on the 40th month of operating activity. This will be March 27. And we can specify and play with these inputs for line 1 and line 2. Then we specify the duration of one shift, how many hours are in one shift. Then we specify how many work days we have in each month inside the typical year. Then we are moving forward to the raw materials library. So here we have the list of all raw materials which participate in our manufacturing process of product A and product B. Here is the price per unit of each raw material. Here we have local and global coefficient for the price. Then we specify if there is any displacement between the moment when we need this raw material in manufacturing process and moment when we actually purchase this raw material. So for example, if we specify and put here 0, this will mean that we need this raw material today and we can buy it this month, so there is no displacement. But for example, here this raw material we may need it today, but we need to purchase it 3 months earlier because we have some logistics chain to get this raw material to our to get it on site. Then we specify how often we purchase this or that raw material. So here 1 means that we purchase this raw material monthly. 4 means that we purchase it once in 4 months, so we can specify how often we purchase this raw material. 12 means that we purchase this raw material once a year and keep it on our warehouse. So then we take the product A and specify what raw materials participate in its production. Here we specify how many units of this or that raw material participates in production of this product A. So here we specify the consumption, and this is the same is done for product B. Then we move to our investment. So we have 24-month long investment plan, and here we specify what we invest in, and here we specify when we invest in and how much we invest in each investment item. And this is the moment when we start operating activity. Then we move to payroll. This is the role that links directly to amount of shifts that we currently have. So this is the name of position on this line 1. This is the salary per person on each position. Here we specify how many people work on this position if manufacturing process goes 1 shift, 2 shifts, or 3 shifts. So here we specify the amount of people. Here we have global coefficients for payroll, local coefficients for line 1 payroll, and local coefficient for specific position if we would like to increase or decrease the level of salary specifically for this or that position. So we can play with inputs the way we want using these coefficients, not the values themselves. So this will ease our scenario play. The same story we have for line 2. Then we move to fixed payroll. So this is the management, office. So here we specify the list of positions. These are the amount of people on each position. This is the salary of 1 person on each position. This is local and global coefficients for these salaries. Then we move to direct payroll. Here we specify. So this is this type of payroll linked to amount of units of product A and product B produced. So here we specify the direct payroll for product A and direct payroll for product B. So how it works? So we specify the name of expense, how many, then we specify dollar per unit, the level of this expense per unit of product A produced. Here we have coefficients for this expense, and then this number is multiplied on the amount of product A produced monthly. The same story happens with product B, and then we move to we start moving to the revenues. So we assume that we have different types of customers for product A and product B. Here we can name these types of customers, and we can split the amount of units produced of product A between these three types of customers that purchase our product. So this is the split for customers of product A, and this is the split for customers of product B. Then we move to pricing. So this is global pricing coefficient. So here we have product A, product B. Inside product A we have 3 types of customers, and inside product B we have also 3 types of customers. And for each type of customer we have its own price. So we have global coefficient for product A, local coefficient for this or that type of customer, and final price will be a composite of global coefficients of pricing, coefficient for product A, and coefficient for customer of 1 till 3 for product A. So all this will be needed for future scenario analysis. This will be very valuable. And then we specify how this customer pays us. So for example, this customer pays us, so we sold the product today, but this month we will get only 30% from the revenues that we're supposed to get. On the next month we will get 20% of what we're supposed to get today, and 1 month further we will get the last 50% of the revenues that we're supposed to get today. So for example, this customer, the price is higher for this customer, but we've sold today, but all the revenue will come on the next month. And here we can specify different algorithms, different payment algorithms for different types of customers. So this will allow us to calculate accurately the amount of operating losses during the first period of operating activity. So we will be able more accurately to calculate the amount of financing needed for the business. So and now we need to finally move to the revenues, and I will copy, for example, the last table. Let's name it revenues. Revenues, the customer done. So what I will do for revenues. First of all, I will delete the formulas from here. Format cells. This won't be a percentage format anymore. Just number. Use this. Okay. And I will need percentage of payment assigned. I will need this table, and for the second component I will this table. So what I will press, I will write a very simple formula, equals, I will take this percentage and multiply it. So here is the let me December. So these are these percentages, and we need to split this, and we need to split the revenue by these percentage values. So transpose, we go to the right. Here we have the revenue values. I'm freezing this column, so this column gives me a total of January 23 revenue. Now I'm pressing enter. And now I will extrapolate this formula to the bottom. And to the right. So what I did in this exercise, I split the revenues on 3 parts of payments. Here they are: 712,800, 712,800. So split this value on 3 payments according to this percentage that we've assigned to this type of customer. So now I'm going back. I will hide this table, and now we'll just copy this table for the rest of our customer types. And now we need to consolidate these. Now we'll consolidate these revenue values. This will be revenues by types of customers. Here I will place types of customers. And now let's consolidate the numbers. So for customer number 6, I will be gathering the data from here. Six, then 5. Then 4, then 3, then 2, and then customer type number 1 finally. Now we'll extrapolate this formula to the right. Then I will consolidate the revenues by products. This will be the line for product A, product B, so this will be for product A totals, and this will be for product B totals. Now we'll extrapolate this formula to the right. So now let's color these lines, these two lines, with green, because these values will go to the cash flow statement. And what I would like to show you, so for example, let's look at December. So the total of December here is 1.6 million. And if we go to a non-displaced revenues, so production allocation between customers, so revenue step 1, if we put this value here and create a total from this group of lines, these revenues don't so payment algorithm don't affect these lines, so the totals will be 10 millions. And this 100% depends on the way. So if we don't use payments algorithms, we won't be able to see the difference between the real money in our pocket from the revenues and the fictional amount of money that may have no connection with reality. So for example, if we say, so everybody will pay us right on the first month, we will see how these values will be equal. So this is if we make assumption that everybody was sold today and we got the money today. But in reality, when we start creating different payments algorithms, we can see that what we sell, what we get, is not what we supposed is. So the revenues, the actual revenues, are much smaller, specifically during the first month of operating activity, than we may think. And this difference between these two numbers may produce operating losses that we may have to finance using our own funds, or a loan, or any other type of financing. So that's why we have to create payments algorithms for our customers to calculate how much money we will need in this case of payments intervals in that case. So this significantly affects the amount of money that we need. So be careful with that. I specifically decided to show you this block of inputs because we can see that if we create a revenue generating algorithm this way with this type of payments, the revenue will be like this. But if we don't have any assumptions and just assume that what we sell will be paid this month, then we will get this amount of money. But in reality we won't get this money, we will get this money, so the difference will be this, and this may cause operating losses that we may have to finance. So this is very important story that I would like to share with you. So maybe this video was useful for you. You may give us a like, subscribe, share this video with your friends. You can also order financial models from scratch for your unique business ideas. We can help you with that. At the end screen of this video I will be giving the link to the playlist where I will be placing all these tutorials, and when the whole financial model will be ready I will be placing all the links on these tutorials in the description of this video as well. So see you guys in next videos. Thank you and bye.